In example 7, they want us to differentiate, so find the derivative of this. Now this is awful. We've got a quotient inside the quotient. Up here we've got a product, and within this product, this is a chain, and down here this is also a chain. So there's really a lot going on, and the best way to do this problem would be to introduce a log, use logarithmic differentiation, and really simplify it down first before you find the derivative. Uh, the steps for logarithmic differentiation, uh, just real quick and simple, are: one, take the natural log of both sides. So you introduce that log, but you have to do it on both sides. Two, keep the equation balanced. Two, then now that you have logs, use your log properties, your log laws, and simplify and reduce it or expand it down to something easier. Three, then find the derivative of both sides. And then four, get y prime by itself. So that's what we're going to do in example 7. Step 1 is to take the natural log of both sides. So you're going to have natural log y equals natural log of all that. And now that I've got a natural log on the right side, I can split this up using those log properties. So here I've got an exponent property. I also have on top a product. Here I've got an exponent of 1/2, and here I've got a quotient, and then here I've got an exponent of 5. So there's a lot to do. So on top, I'm going to split the x to the 3/4 and the square root. So it's going to be 3/4 natural log x plus 1/2 natural log x squared plus 1. Now this is all the top. So what I did was I brought the exponent in front of the natural log. I added, because we're multiplying, and I took the square root and made it a 1/2 and brought that in front. And so that's the top. The bottom, then you subtract for dividing, and that 5 will go in front. And so that is fully expanded out. And actually, to me, looks a lot easier than doing what we would have done up there. So again, I've got the top, the exponent came in front, plus the top, the 1/2 came in front, minus the bottom, the 5 came in front. And then we want to go through and find the derivative of both sides. So we're going to have derivative natural log y is 1 over y, but we're differentiating with respect to x, so it gets a y prime next to it. Here I've got a constant, so 3/4 stays in front, and then I do derivative of natural log, which is 1 over x. 1/2 is a constant, stays in front, and then I do natural log of, or derivative of that natural log, which is 1 over x squared plus 1. And then derivative, this is a chain rule, so then derivative of the x squared plus 1, which is 2x, minus 5 is constant. And I've got another natural log, so 1 over 3x plus 2, and then I do derivative of the 3x plus 2, which would be 3. So that's the derivative of each piece. And then we want to simplify this and try to solve for y prime. So we want to get y prime by itself, but also this is a mess over here. So I'm going to put y prime on top. This will be 3 over 4x. Here my 2's cancel, so this would be x over x squared plus 1. I can put my 5 and my 3 together and make negative 15. Now here I could work on getting common denominators, but it doesn't really seem worth it, so I'm just going to kind of leave it as it is. And I want to get rid of this y now. Remember, the goal is to solve for y prime, so I'm multiplying both sides by y. And so this is what I've got. I've got all this times y, and then what you want to do last is you don't want it in terms of y if you can change it. And so at the beginning, we know what y equals. So I'm going to just put that instead of y, substitute in the original value of y. So I've got 3 over 4x plus x over x squared plus 1 minus 15 over 3x plus 2 times the original function, which is the y, x to the 3/4 times square root of x squared plus 1 over 3x plus 2 to the 5th. And that is as simplified as I would take it.